Hi class, and welcome to lesson 3.8, solving linear and quadratic systems. Here are our warm-ups. First of all, we're going to check on our graphing skills from grade 9, 10, and 11, and then we're going to use that to help us solve linear systems. So first of all, we're going to graph A. A is a linear equation. So taking a look at that, ladies and gentlemen, we know that B equals 5 and m equals -2 over 1. So what we're going to do with that, ladies and gentlemen, is we're going to start at 2, and we should put a little scale on our graph here, guys. -2, -2. Okay, just fix this up. All right, so I'm going to start at my y-intercept, which is 5. So 1, 2, 3, 4, 5. I'm going to put a dot. From there, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. That's going to get me to draw a nice straight line. Which should go right through here. I'm just going to quickly edit this line to make it a good color and to make it match, and to change my start value because you need arrows. Okay, so that's example A. Example B, ladies and gentlemen, I will do in black. Okay, again, it's a linear equation. What do we know? We know that the y-intercept equals -1 and our slope equals 3 over 4. So I'm going to start at -1. And then from there, ladies and gentlemen, I'm going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. Do it a couple more times. 1, 2, 3, 1, 2, 3, 4. Okay, to get a nice line. And again, I'll use you can use a straight ruler for that. I'm just going to graph those. I'm just going to change the properties of it so that it has arrows at both ends because it is a function. All right. Now in grade 9 and 10, ladies and gentlemen, just so you know, we paused at this point and we said, okay, what's the point of intersection? And we looked for where they cross. We're going to do something similar to that, but instead of using linear versus linear, we're going to compare a linear versus a quadratic. So looking at example C, we have a quadratic formula. Our vertex, ladies and gentlemen, is 0 and 4. And if we apply the step pattern, which is A times 1, 3, 5, we're going to have -1 over 2, -3 over 2, and -5 over 2. Okay, so we plot our vertex, which is at 0 and 4. All right. So 0 and 4, 1, 2, 3, 4. We notice the direction of opening is down. That's why our step pattern is negative. So as we go over 1, we go down 1/2. As we go over 1, we go down 1 1/2. And as we go over 1, we go down 2 1/2. Okay, and then we draw our parabola. Okay, last one. This one's a little harder because it's not in vertex form. But what do we know? We know that our zeros are -1 and 3. So I'm going to plot those as my zeros. I'm just going to, change my color here, guys. So pretend this one's green. Okay, so we're going to go -1 and 3. And then what we're going to do is realize we can use x equals -1 plus 3 divided by 2. We can find our axis of symmetry. So x equals 1 in this case. And then we sub that into the function in order to find our y value. So we sub 1 plus 1 times 1 minus 3. Use your calculator or your brain, and you can get that to be -8. So what do we know? The vertex equals 1 and -8. So taking a look, ladies and gentlemen, our vertex is 1, -8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use my step pattern just to help me to make sure that we're on the right track. So A is 2, so it's going to be over 1 up 2, and then over 1 up 6, and that will indeed get us to our x-intercepts to match. Okay, there's a quick review on graphing, ladies and gentlemen, because that's one possible tool that we could use to data graph. Now we're going to review a bit of radical work, simply because it's kind of new and unfamiliar. I'm just going to move question B over because it is going to take me a little bit longer to do question A, so I apologize for that. Just move it over a little bit more just in case, so I want lots of room for A. All right, so what we're going to do, folks, is we're going to use a shortcut for squaring a binomial, but this time we have a radical in it. So the first thing we're going to do is square the first. So when you square the first, it's going to be 3 root 5 times 3 root 5. Then double the product. So plus 2, that's double, times the product. So it's 3 root 5 times 2 root 4. And then we're going to square the last, which is 2 root 4 times 2 root 4. And again, you could still use expanded out, use FOIL. However, you're going to have 4 things to multiply instead of 3, so I think this is the shortcut way to go. When we multiply, 3 times 3, guys, is 9. And I want you to think about this. What is root 5 times root 5? It's really square root of 25, which is really 5. So when you square something and you have a square root of something, those two are opposite operations, so they cancel out. It's kind of neat there, isn't it? All right. Taking a look at our middle term, 2 times 3 is 6 times another 2 is 12. Root 5 times 4 is 20. And our last term, again, 2 times 2 is 4. And let's think about this. Root 4 times root 4, when you square and you square root it, they cancel each other out. So you end up with 4. Simplifying this further, we have 45. And we want to simplify our middle term because this is not in lowest terms as our terms of our radical. So it's going to be 12. We can break that down into 4 times 5. Okay, plus 16. I'm going to collect like terms here, folks. I have 45 plus 16, which is 61. And then I'm going to do this in 2 steps all together. So currently I have 12. When I take my root 4 out, that's going to be 2, right? So 2 times 12 equals 24 root 5. And there we have that completed. Taking a look at our B part, ladies and gentlemen, this is the 3rd root of 54. So you can't use your square root symbols or square root matrix. You need to use a cubic list, and hopefully you have 1, 8, 27, what's next? 64, 125, and 216 somewhere as a list of cubic numbers. Then we examine this cubic root, and we're going to break it into 27 times 2. When we take the cubic root out, guys, cubic root of 27 is 3. And then what we're left with still is root 2. So it's 3 times the cubic root of 2. There's our warm-ups, and now we're going to get into our lesson today. This is our last lesson of the unit, folks. We next have a review and then a unit test coming up. So hopefully you're prepared, and again, come see me if you need some help. So let's just recall linear systems, solving 2 or more of them. In grade 10, we learned that we found out how to find the point of intersection. We call that P of I for short form. You can use that on your test with me. I'm okay. We did that by graphing, or we solved it algebraically by using substitution and elimination. The easiest one we're going to use today is the substitution method to help us. When we're looking for solving a linear quadratic system, that means we're going to find the points or point, because sometimes you may just have one or none, of the intersection of a line, because that's the linear part, and a parabola, because that's your quadratic part. Okay, so what does this mean? We could have a possible of no solution. So let's just think about what our graph could look like. Our graph could have our parabola being really high up here, and then maybe our linear relation down below. Notice they won't cross, so that means there'll be no solutions. Or you could have the other option where you have your line up early, and then you have your parabola down below as long as it opens down. Again, in both those cases, folks, there is no intersection or crossing of lines and curves. Where we have one solution, ladies and gentlemen, there's two ways you can do this. The first way is if you have a line and then your vertex is on the line. Okay, so that's vertex on line. And the other special case, if you've got your thinking caps on, which is a little hard to think, is if I have my parabola here, ladies and gentlemen, and I have a special type of line, which is called a vertical line. Okay, those are all the possibilities that will show you no solutions or one solution. The other option is to have two solutions, and that shows you everything else. So basically, you're going to have a parabola, and some point along the parabola, you're going to have two solutions because there's going to be 2 points of intersection. All right, let's do an example of graphing. So we're going to graph quadratic and a linear and find the solutions. So the first one basic is our basic or our parent function, ladies and gentlemen. So we're going to start with this, use our step pattern at the origin, over 1, over 1, up 3, over 1, up 5, 1, 2, 3, 4, 5. Okay. So there's our quadratic, or in this case, this is f at x. Now we're going to compare it to g at x. Okay. And g at x is linear, so what do we know about linear? Okay. We know that b equals 2 and m equals 1. So we're going to start at 2, and from 2 we're going to go up and over 1, or you can follow the same path. And I'm just going to try and eyeball this one, folks, just because I'm in interest of time. Okay. So if you wanted to show some work for how you graphed f at x, if you're saying, hey, Mazar, where's my communication? You would tell me its vertex is 0, 0 for my ordered pair. And you would say that my step pattern is 1, 3, and 5. That's how you graph the first one. You've showed me how you graph the second one. Now what we need to do is take a look at the p of i's here. So on your paper, you write p of I. And what do we have? We have two of them. We have one that's at -1 and 1. And one here that's at 2 and 4. So then over here you say, therefore, there's two solutions at, and give your ordered pair, -1, 1, and 2 and 4. That's how you do it graphingly. And remember, we had problems in grade 10 with graphing because it only is accurate if they meet at the crosshairs like they did in that example. There are times and cases where they do not always meet at the graphing graphing hairs. So we have to use method 2, which is solving algebraically. I'll go over these steps to help you, ladies and gentlemen. It's very similar to grade 10, but we're just adding a little bit onto it. So, step number 1, if we're using substitution method in grade 9, you had y equals something and y equals something, and then you substituted in y for y, right? So it's a substitution that we're doing here. So step 1 is let f at x, because that's really y, equal g at x, which is also really y. So what does that mean? That means that we're going to have x squared minus 4x plus 1 equal -7x plus 5. Okay. Step 2 is to get one side equal to 0. So we're going to move all our terms to the left. So doing so, we're going to collect like terms. So we're going to have x squared plus 3x when you collect terms, and minus 4 equals 0. Once you've got the one side to 0, then we need to solve. So step 3 is to solve. And how do we solve, folks? You either factor or quadratic formula. So factor, try a couple minutes, see if you can factor, or quad formula. Let's see if we can factor here, folks. So product equals -4. Sum equals 3. What values do we get there, folks? You're going to have 4 and negative 1. So this is easy to factor, folks. So it's going to be x plus 4 times x minus 1 equals 0. Don't forget that we haven't solved it. We have just factored it. So x equals negative 4 and x equals 1. That tells us already that we know there's two solutions, but we only have the x part of it. To find the y part, we've got to sub those into f at x and into g at x. So step 4 is to sub x values into the function. Okay, so instead of g at x, I'm going to write g at negative 4 equals negative 4 times negative 7 times negative 4 plus 5. Using your calculator, that equals 33. So I've got one answer there. And the second one, g at 1. Question could come up, hey, Mrs. R, why did you use g at x instead of f at x? I'm going to always choose the easiest substitution. You'll get the same answer if you sub those values into f at x. But again, I'm always going to look for the easiest method to save myself some time and less room for error. So what we have, folks, is we have our work done here. The last step, which is step 5, is to just summarize your solutions. Okay, so state the P of i's. Okay, and remember you put them in ordered pairs. So therefore, the two solutions are negative 4 and 33 and 1 and negative 2. So that's how you find the actual solutions. Now, ladies and gentlemen, we're going to do a different type of question, which is find the number of solutions. Okay, and please note, ladies and gentlemen, these are different expressions than above, so don't automatically tell me there's two solutions, okay? And when we're finding the number of something, we learned that we could use the discriminant. And for those who forget what the discriminant is, it's b squared minus 4ac. So step 1, like we did before, we have to let f at x equal g at x. So let's do that. So we're going to have negative 2x squared plus 1 equals negative 3x minus 2. And again, in order to use the discriminant, we need to have all the values on the left side or one side. So let's move them all to the left. So step 2, get all the terms on one side. Okay, equals 0. And then once you've got equal to 0, then you can use the discriminant. Okay, so use b squared minus 4ac. Let's sub that in. So it's going to be 3 squared minus 4 times negative 2 times 3. And we end up with 33. If this number is greater than 0, that tells us we have how many? 2 solutions. So therefore, 2 solutions because the discriminant d is greater than 0. All right, remember, it asks for the number, not the actual values. All right, I've got one more example for you, and it's a tricky one. It's your level 4 type inquiry question. So let's see if we can do it together. Example 3. Determine the number of points of intersection at g at x and f at x without solving algebraically. So the only other way we could do it is using graphing, or the graphing method. Okay, that's the frustration. The good news is we've got one linear expression. We can easily graph that. We already know that our y-intercept equals 1 and our slope equals 7 over 1 if we're going to plot that. The frustration here, ladies and gentlemen, is that f at x is in standard form. So how do we graph, okay, how do we graph an expression that's in standard form? So to get an expression that's in standard form, hopefully you remember the rule by now, folks, is we're going to complete the square because we need the vertex. Okay, so let's do that. And the frustration is going to lie here, folks, that we're going to have some fractions. So just have some patience as we do this. Okay, because we need the vertex, right? That's why we're completing the square. All right, here we go. So first rule, ladies and gentlemen, is to factor out a out of the first two terms. So it's going to be x squared minus 5 over 3x plus 2. Next, we're going to do our margin work over in the side. So it's b divided by 2, which equals negative 5/3. And then you're dividing that by 2. The rule of thumb is you've got a divisor of 3 and a divisor of 2. That's just going to be a divisor of 6 because you multiply your denominators. Or folks, just use your fraction button on your calculator and you should get that. Okay, then don't forget we need to take that value and square it. So we end up with 25 over 36. That's the number we're going to add and subtract inside our brackets. So we add that in now. It's going to be plus 25 over 36. Subtract 25 over 36 and plus 2. Just remember, folks, that we use the first 3 to complete the square, so let's do that. So we're at the end of the unit. We can skip a couple steps here. So the first 3, if we complete the square, it's going to be x minus 5, 6 and squared. Okay. Then remember, folks, we need to bring this fraction outside, and it's times by 3. So it's going to be negative 75 over 36 because it's got to be factored by a. And then remember, we got to get, this is a constant term, this fraction, and 2. So how do we make 2 out of 36? You times it by 2, so it's going to be 72 out of 36. Almost done, ladies and gentlemen. So what do we have here? When we simplify this out, folks, we're going to have negative 3 over 36, which will finally simplify because that fraction can be in lowest terms. It will simplify to negative 1/12. Wow, that was a lot of work, eh? So just let me move this down for a sec, please, so I've got more room. All right, almost done, guys. We can do this. So now we know our vertex is negative 5, 6 and negative 1/12. Okay, and you actually don't need an official sketch. You can just sketch it. You don't need an official grid for this. So plotting 5, 6, guys, it's tricky, but make this a 1 and it's 5/6 of the way. And then make this negative 1. Okay, and you're going to notice that it's really close, but not on the axis. Okay. All right. I apologize. It's not negative 5, 6. It's positive 5, 6. So can you guys make that a positive? I just took that out wrong. Okay, I forgot that the negative is part of the equation. So it's 5, 6 and negative 1/12. And a is 3, so it opens up. It doesn't matter your step pattern. We're just going to open it up. Okay, because what we already know, folks, is we already know from above that the linear equation, g at x, we're going to start at 1, and then it's going to have a step pattern of 7 and 1. So what do we know? We know it for sure crosses once here, but as these functions continue, we know it's going to cross here again. So our answer is, how many solutions do we have here? It is 2. So therefore, 2 solutions for f at x and g at x. All right. That ends our lesson today, folks. And this is our last official lesson of this unit. We have a review lesson, just summarizing everything, and then we're getting ready for our test. So hopefully this is a good exercise for you. And again, see me if you need extra help. Here's your homework, page 198, numbers 1 to 3, 6, 8, 9, and 10. Have a great day, guys.